which monomer is best able to undergo anionic polymerization. So our anionic polymerization that we're looking at here is with substituted ethylenes. So this is again a chain growth polymerization. The active intermediate this time is going to be an anion. So our chain growth polymerizations can occur with 3 different types of reactive intermediates. It could be a free radical, it could be a cation, or it could be an anion. So in the case of anionic polymerization, you're using a really strong base to generate that reactive intermediate. So something like butyl lithium is often used. And so this is going to attack the end carbon atom of your substitute ethylene and put an anion on the next carbon. And so it's the anion here that we want to focus on to say which of these monomers is going to be best. So let's take a look at the structure that we're forming here. So we've added the butyl chain, and then we're going to have our CH2, the CH with whatever our X group is, and this is where we form an anion. And so then this anion can add to another molecule of the monomer. And this will grow the chain length and generate a new anion to be a reactive intermediate. So we can see our repeat units here, these 2 carbon atoms with the substituent. And now we've got another CH2, and we've made another anion. And that should just be 1 carbon. Then we have another anion. So what we need for X then, in order to have a good anionic polymerization, is we need this X group to be able to stabilize an anion. And what that means is we really need this to be electron withdrawing. So we're looking for something that can be an electron withdrawing group. So if we look at A, we've got 2 methyl groups. These are both electron donating groups, so that's not what we're looking for. If we look at B, we've got these lone pairs of electrons on oxygen that can also be electron donating. So that's also not what we're looking for. We get to C. This nitrogen also has a lone pair of electrons, so this is also an electron donating group. And finally, we get to our last option. We've got this pi bond to an electronegative atom. This is going to be electron withdrawing. And so that means that this monomer would be able to undergo this anionic polymerization.